7. Today our lesson is on arc length and perimeter of sectors. Now there's some words we've heard before. We've heard about arcs and we've heard about sectors. But what does that mean when we're talking about perimeter? So in the last couple of lessons we have had our circles and we've been trying to find the circumference, which is the distance around that whole circle. If I want to find an arc length, that means I only want to take a part of that circle's circumference and I want to find how long that is. Now, it might be a quarter of the circle, which is what that one looks like. It could be half a circle. It could be any number of degrees inside that circle. So there's going to be a few formulas that we're going to be looking at today. So let's start with this table that is here. Complete the table below. If I wanted to find the arc length of a sector that was 180 degrees in my circle, so I won't draw these for everyone, but that would mean here is my circle. I want to have the full 180 degrees, which would be like a straight angle in there, and I want this much here of my circumference. Now there is 360 degrees in a revolution as you go around that circle there. So what we do is we go, all right, if I have 180 degrees, I want to put that over 360 degrees, which tells me that I actually have half of a circle. So if I know that the formula for circumference of a circle is pi d, that was one of my formulas, remember, for circumference, I want half of that circumference, so it makes sense that I do half times by pi d. What about if we had a right angle for our sector? That would mean that we put the 90 degrees over 360, which of course is a fraction that will simplify, and that simplifies to a quarter, which means I would do a quarter times by pi d. So basically all we're doing is we're taking what fraction of the circle do I have and timesing it by the circumference formula, which in this case I'm choosing pi d. You could also use 2 pi r if you had been given the radius, which will probably happen quite a lot for these sectors. Okay, so for the 45 degrees, let's fill in this table. We would put 45 over 360 degrees. That simplifies to be 1 over 8. Remember, you can use your calculator to simplify these. So if you type in the fraction, you put in 45 over 360 equals, and it simplifies that for you. So if I was trying to find the arc length, which we're calling little l, now I'm writing a capital L because little l's, they either look like ones if you draw them like that, or you have to try and draw them as a script kind of L, which can be tricky as well. So I don't mind if you change the little l into a capital L because they just look less confusing. So L for arc length. This time I want an eighth of my circle, and I times that by my circumference formula, which is pi d. If I have 30 degrees, I put that over 360 and simplify it. That gives me 1/12 of a circle. So L would be equal to 1/12 times pi d. If I had 150 degrees, I would put that over 360. I'd simplify it down to 5/12, and I would get the formula L is equal to 5 over 12 times pi d. Now, we don't want to have to remember all the different angles, so instead we want to work out a formula that we can use anytime, no matter what angle we're given. So we introduce this symbol theta. Okay, it is a Greek letter called theta. To draw it, all you need to do to draw it is basically you're doing a 0. So you go around like your 0, but you do an extra little loop on the inside. That's how you draw a theta. And all that means, it's like algebra, it is just representing the number, or in this case, the angle that we are given in our question. So whatever angle we're given, which is going to be called theta, we're going to divide that by 360, which means if I wanted to find the arc length, I would take the angle, I would divide it by 360 and times it by my circumference formula. Okay, we're going to keep talking some more about that, so don't be too worried if that's still a little bit fuzzy. Let's fill in some dot points down here. A circular arc is a portion of the circumference of a circle. So that's what we're trying to find. We're trying to find part of the circumference of a circle. We're using this letter theta, which is our circle with a little extra loop in it. Theta, that's how you spell it. It's a Greek letter and is used to represent the angle that the arc makes at the center of the circle. So here is a diagram. If this is the angle that we're trying to find, we're trying to find the length of this arc around here, then we would need to know how many degrees that theta is. So there's two formulas that we come up with. Now we just found one of them. The L is equal to theta over 360 times pi d. Here it is again. L equals theta over 360 times by pi d. But remember that there was two formulas for the circumference of a circle. The other formula was C is equal to 2 pi r. So you could also use that L is equal to theta over 360 times by 2 pi r. It looks really messy, it looks kind of complicated, but it really is just whatever angle you're given, divide that by 360 and times it by the circumference formula. Now, there is one extra catch. When you use that formula, it calculates the length of the arc. If I was wanting to find the whole perimeter of that sector, meaning that whole wedge of pizza that I've got there, the perimeter means all of those sides have to be added together. So on the next page, if I was wanting to find the perimeter of a sector, you must find the length of the arc and then add on 2 radii. Remember, that's the plural for radius. We need to add on 2 radii. So in this case, we would have the theta over 360. We would times that by 2 pi r. That's our formula that would tell us the curved part of our sector. So looking back here, we get that red curved part. But then I have to add on 1, 2r. So there's my plus 2r for the 2 straight sides that need to be added on to complete that perimeter. So you're going to have 2 types of questions that you're going to do today. The first type of question is like example number 1 here, where you just need to find the length of the arc. Okay, so that is using these first 2 formulas here. L is for arc length, L for arc length. Okay. And the second type of question is finding the full perimeter, which is when you'll be using this second formula, this second box here. So question number 1, find the length of the following arcs, correct to 2 decimal places. So in question 1a, I'm trying to find the length of this little curve here. So using my formula, well, there's actually 2 of them, I need to work out, is this 10 centimeters that I've been given, is that a radius or is that a diameter? Well, most of the time for sectors, because sectors are made with radii, then you will be using the C equals 2 pi r formula. So in this box up here, this one here is going to be the most commonly used formula because sectors use the radius. So let's write that formula down. L for arc length is theta over 360 times by the circumference of my circle, which is 2 pi r. Now remember that theta, I'm sure it's still a little bit scary for some of you, but it just means what angle do I have? And I have a 50-degree angle. So all I need to do is put 50 degrees on the top of that fraction, divide it by 360, and times by 2 pi. But instead of r, I want to put in that the radius is 10, so times 10. Then the third line, like always, is to type that in your calculator to find out an answer. So using the fraction button, we have 50 over 360 times by 2 pi times by 10. And we're doing 2 decimal places. So that will be 8.7. It'll have to round up to be a 3, 8.73 centimeters. So just like when we were doing normal circumference, we want to see 3 lines of working out. First line, I want to see your formula. Second line for the substituting. And the third line is for your answer. 1b, we're still using the same formula. We're still trying to find the arc length. It is a big arc. It's a really big one that goes all the way around here. The dark line is the one we're trying to find. So to find the arc length, again, we're given the radius, so we're going to be using theta over 360 times by 2 pi r. Now, the theta represents the angle. The angle in my sector is 225 degrees. So that goes over 360, and I times by 2 pi times the radius, which is 16. Type it in your calculator. 225 over 360 times by 2 pi times the radius, which is 16. To 2 decimal places, that's 62.83 centimeters. Okay, so when you get to your exercise, you're going to have, from memory, I'm pretty sure it's a whole page of those where you are going to just be finding the arc length using the formula like I've done just there. Then your second page is going to be like this question number 2, where I want to find the full perimeter of the sector to 1 decimal place. So to do the whole perimeter, I need this formula here in the box. So it's now P for perimeter equals theta over 360 times by 2 pi r plus the 2 extra radii that we need to close that shape up to go all the way around. So write the formula down as the first line. Second line, substitute in. Now theta is my angle. I have a right angle in there, so that means 90 degrees. 90 over 360 times by 2 pi times the radius. My radius is 3. So that's the normal arc length part, but we still have to do the plus 2 more radius, so that's 2 times by 3. Remember to put that times sign in and into the calculator. 90 over 360 times by 2 pi times 3 plus another 2 times 3. So 1 decimal place will be 10.7. Don't forget the units, which are meters. So let's do that one more time. We're trying to find the perimeter of that sector in there. So you'll see this in your worksheet as well. It's the dark line that you're trying to find the arc length of, and then hence the perimeter. So write the formula down. P equals theta over 360 times 2 pi r plus the extra 2r. So theta is my angle, in this case 120 degrees, over 360 times by 2 pi, and my radius this time is 13. So 2 pi times 13 plus the extra 2 times 13 for adding on the extra sides. And finally, the last step is typing it all in. Be careful with this step. Be surprised how many people can make mistakes typing things into a calculator. Probably the most common mistake is this plus sign. A lot of people turn that into another multiplication sign. So that's probably the biggest thing you need to be careful of. So my final answer is 53 point. Now I want 1 decimal place, so 53.2. And that's in kilometers. Okay, so here is your work. We're up to exercise 5. Hopefully you've finished the first 4 already. Exercise 5, page 15 and 16 today.